So one thing that you must understand with regards to mastering this topic, electricity and magnetism, as you are now going to work with electric circuit, you must be able to do what? You must be able to understand the electrical symbols, because each and every time you deal with electricity, there are symbols that are going to be there. For an example, let me just introduce them. You can just write them down. These are electrical symbols. So it means to say, when I'm saying electrical symbols, they are gonna show them every now and then using symbols. When you have a symbol that is like this, for an example, you must understand that it represents an ammeter, and then it has a capital letter A inside. So this one, it's an ammeter. So that one it's an ammeter, and then you're gonna have another one that has V here, which we call the voltmeter, and then you're gonna also have another one that represents a light bulb, which is like this. So the one that represents a light bulb is kind of like a light. So every now and then you see a symbol that is like this, you must understand that it represents a light bulb. Or if you don't say a light bulb, you can just say it's a lamp. It's a lamp. And then you're gonna also have another one which we call a resistor. Why am I showing you this? It's because of these things, they don't change, and you're gonna go with them up until you go to tertiary level, if maybe you're gonna do engineering, like electrical engineering, because it's electricity. So this one, you call it a resistor. So you'll see that on the circuits that basically we'll be working with, they will be giving us a resistor, and then we're gonna have another one which we call a battery or a cell. Now this one, you know it. It's like this. Then here it's like this. This side it's like this. So this one, we say it's a battery. This one, it's a battery, right? And then if you don't say it's a battery, some textbooks, they normally say it's a cell. It's one and the same thing, And then one thing that basically you must understand from here, I'm not gonna, because there are many of those, I'm not gonna show you all of them. I'm just gonna show you the ones which you're gonna only get at your level as a grade 10 student, because there are many of this. So there's another one which is like this here. Now this one is like this. So it's like this. We call it a switch. This one we call it a switch. And since it's like this, it's open here. You can see here. It's basically open. So that will be us now saying that that is a what? That is an open switch. So these are the basic electrical symbols that you must know as a grade 10 learner. Any question? Can I proceed? So, okay, sure. So now let's speak about energy symbols, energy sources, so to say. So one thing that you must understand is that electrical energy is provided by sources. Electrical energy is provided by sources. Electrical energy is provided by sources such as a cell, right, battery, or a dynamo. So one thing that you must understand is that a battery is a combination. A battery is a combination of cells. So here you can just see I said it's gonna be a battery or a cell, because a battery is a combination of cells. Ne? And one thing that you must understand is that cells can be connected. You can just make a dot. Cells can be connected in series, or they can be connected in parallel. Ne? And one thing that you must understand is that the EMF, the EMF, now for you to understand, when we speak about the EMF, we're speaking about the electromotive force. So this EMF is just a word that is being abbreviated, but it simply means electromotive force. So the electromotive force of a cell, is the maximum quantity of electrical energy, of electrical energy, is the maximum quantity of electrical energy that can be supplied per coulomb, Now one thing that you must understand is that the charge is measured in coulomb. Ne? That can be supplied per coulomb of charge. Electrical energy that can be supplied per coulomb of charge when no current is flowing, per coulomb of charge when no current is flowing through the cell, through the cell. Then you can just say a full stop right there. So this one you must also understand is that the symbol for EMF, which means electromotive force, is capital letter E. So where you'll be seeing a capital letter E here, you must understand that it represents what? It represents the symbol for what? For an electromotive force. So you'll come across the term electromotive force. So you must just understand that. Ne? And then as you are continuing, so you must know that cells are connected in series. Cells are connected in series. Cells are connected in series when their terminals are connected in a positive to negative. When their terminals, I'm just gonna show you just now. When their terminals are connected in a positive to negative sequence. So remember a cell, I've just showed you to say a cell or a battery is like this. So it means that here it will be a positive, here it will be a negative. So these are just the terminals of a cell. These ones are just the terminals of a cell. So here we are saying what? We are saying cells are connected in series when their terminals are connected in a positive to negative sequence. So when they're connected to positive or negative sequence, what do I mean by that? Now you understand that a cell is like this, right? So they're gonna be in series if they're connected from what? Positive to negative, just like that. And then one thing that you must understand is that the total EMF of a battery, or the total electromotive force, the total EMF of a battery of cells connected in series, of cells connected in series is the total EMF, is the total EMF or total electromotive force so the total EMF of the battery of the cells connected in series is equals to the, okay, let me see, just a second. The total EMF of a battery of cells connected in series, yes, the total EMF of a battery of cells connected in series is equal to the algebraic sum, or you can just say it's equals to the sum, or it's equals to the total algebraic sum of the EMF's individual cells, of the EMF individual cells. Let me show you what do we mean by that. Individual cells. This means to say, when I'm saying the total EMF, remember EMF or electromotive force is shown by capital letter E. It means to say it will be what? ET. That means the total electromotive force, it's equals to E1, maybe let's say plus E2 plus E3. So this statement right here, when I'm saying this equation right here, it justifies the statement that says the total EMF of a battery of the cell, which we know that is gonna be E total in series, it's gonna be equals to the sum of the algebraic EMF of the individual cells. So that's what you must know there. Then with regards to that, let's look at the resistors that are connected in series. Resistors connected in series, because when you are working with electricity, you will come across resistors every now and then. Resistors connected in series. So before you can be able to know the resistors connected in series, you must just understand the symbol that we are using for a resistor. Now a resistor, it's used by the following symbol, which is this one, right? Now with that being said, it means to say, now for me to speak about the resistors in series, I know that I can do what? I know that I can put 3 resistors in series as follows. So when we speak about the 3 resistors in series, we are speaking about the following. And then you must understand that R1, it will represent our resistor number 1, R2 is our resistor number 2, R3 is our 3rd resistor there. And then when they are in series, they're gonna be connected, or they're gonna be shown like that. And the SI unit for a resistor is that the resistor is measured in ohms. Ne? So let's say they are saying this is a 3 ohm resistor. The 3 ohm resistor, the SI unit of a resistor, it's ohms. Ne? And then let's say that is a 5 ohm resistor, and then let's say that is a 7 ohm resistor. So don't forget that the resistor is measured in ohms. So this symbol, it means ohm. This one, it means ohm. And we know Ohm's law, right? I'm just gonna teach you. So since these 3 resistors are connected in series, if they were to say calculate the total resistance, so the total resistance of this, we're gonna say R total. We're gonna say R total, it's equals to resistor number 1 plus we add the resistor number 2, which is the 2nd resistor, we add the resistor number 3, which is the 3rd resistor. And then R total, which means the total resistance of the circuit that we are having here in series, is gonna be R1. So in a place of R1, we're gonna put what? We're gonna put or substitute 3 ohms. You're just gonna write 3 ohms plus, and then your R2 is gonna be what? 5 ohms plus, it's a matter of substituting. R3 is gonna be 7 ohms here, just like this. Ne? And then you're just gonna say RT, it's equals to, now you add 3 plus 5 plus 7. Let's add 3 plus 5 plus 7. It's gonna be what? Let's add, can you hear me, guys? Yes, it's gonna be what? Goodness. 3 plus 5 plus 7. Eh? Yeah, it's gonna be 15. So you're just gonna say 15 ohms. So this 15 ohms is what we call the total resistance. This 15 ohms is what we call the total resistance. Total resistance of this circuit that is in series circuit. So that's how basically it is. And then with regards to that, you must understand that also, since now you have calculated the total resistance of the circuit, it's not difficult. It's just need you now to know this, right? And then with regards to that, let's now see what is Ohm's law. Let me just write it for you, because they will just ask you to define Ohm's law before you can do what, before you can calculate or do any calculations that has to do with the electricity, ne? So Ohm's law, I'm just gonna write it here. Ohm's law. So what they will do, they will just say state Ohm's law, ne? You'll just say state Ohm's law states that the electric current states that the electric current through a conductor the electric current through a conductor between 2 points is directly proportional to the voltage across the 2 points. It's directly proportional to the voltage across the 2 points. It's directly proportional to the voltage across the 2 points, right? And then since now you understand Ohm's law, because there's no way you can calculate or do these calculations without you now stating Ohm's law. So you'll have to state Ohm's law first. To say Ohm's law, they will say define what is Ohm's law. You must tell them to say Ohm's law states that the electric current through a conductor between 2 points is directly proportional to the voltage across the 2 points. So that's what you are gonna state or define with regards to Ohm's law. Now, after you are now understand Ohm's law, it means to say you must understand the following triangle. Now, this triangle is the one that basically defines Ohm's law that we just basically stated just recently. You must understand this triangle. So this triangle is the one that is going to give you what? Is the one that is going to give you the formulas that we are working with, because in electricity here or in Ohm's law, we are normally working with voltage, current, and the resistance, ne? So here basically you're gonna get what? You're gonna get V, and then here you're gonna have I. Don't worry, you'll understand it now. And then here you're gonna have what? Here you're gonna have R. Here you're gonna have R. So you must understand this. So this is a triangle that best define what? Ohm's law. Ohm's law. So we recently did define Ohm's law. You must know it by heart. Ohm's law states that the electric current through a conductor between 2 points is directly proportional to the voltage across the 2 points, right? And then with regards to that, you must understand that V here on the triangle stays for the what? For the, it's equals to the voltage, and the voltage is measured in volts, capital letter V. It's volts. And then I stands for the what? For the current. Then current is measured in amperes, capital letter A, ne? And then R stands for the resistance. Resistance is measured in in ohms. In ohms, it's measured in ohms. It's measured in ohms, just like that. So these are some of the things that you must understand. So this V, it means volts. Then this A, it means amperes. Then that one is stated there. Now with regards to this, it means that now since you understand this triangle, there are formulas, right? So there are formulas for calculating what when you calculate voltage. So here I'm just gonna say calculating voltage, and then here I'm just gonna say calculating current. Then lastly here I'm just gonna say calculating resistance. So now this is me now trying to show you the formula that you are going to basically use. So if they say calculate the voltage, you must understand that you're going to use the formula that says V is equals to IR. V is equals to IR. Ne? It's V is equals to IR. It means to say here there's a multiplication, even if they didn't write it. So V, you understand that V there, it means what? You are calculating voltage. Now the second one, we are calculating current, is I, which is current, is equals to what? It's equals to V over R. V over R, right? And then when we are calculating resistance, lastly it will be R, which is resistance, is equals to V over I. So where am I getting this from? It means to say, the moment you know it from the first formula right here, V is equals to IR. If they wanted to calculate the current, you just simply make I the subject of the formula. You divide both sides by R, like divide by R, divide by R. You see, this cancels that. You'll be left with I is equals to V over R. That's why here we're having I is equals to V over R. So in simple terms, I'm just trying to say it's now you substituting from the original formula. If you know one formula to say V is equals to IR, then everything is now going to make sense to you. Everything is now going to be very easy, just like that. Ne? Any question? Any question? So if there's no question, we can now continue. Let me see my time. So we can now continue. I was not aware that you went outside, goodness, but we can now continue. So those are the formulas basically. And then with regards to that, I think when now you have these formulas, you are not gonna struggle, ne? So Ohm's law, we did it. Now let's because here I've just said the resistors connected in series. Now let's deal with the resistors connected in parallel. Resistors connected in parallel. So when you have resistors connected in parallel, it means to say parallel resistors, they're gonna be as follows. You can have one there, it doesn't matter how many they are. In most instances they are likely to be 3, but at the end of the day these are just resistors connected in what? In parallel. So when you speak about resistors connected in parallel, we're speaking about something like that, right? And then remember, this is going to be R1, which is resistor number 1, R2 resistor number 2, as well as R3 resistor number 3. Now in this case I'm just going to make examples. Let's say this one we are given 6 ohms, and then this one we are given 3 ohms, and then this one we are given 1 ohm. And then the question may arise where they want you to calculate the total resistance. So the question can arise, they can tell you to say calculate the total resistance. Calculate the total resistance of the circuit. Now before you calculate the total resistance of the circuit, you must understand which formula do we use with regards to calculating the total resistance of the resistors connected in parallel. Now if you remember, the one that we had previously of calculating the resistors connected in series, it was this one, RT is equals to, you see, RT is equals to R1 plus R2 plus R3 plus, just like that, you see, because they are connected in what? Because they are connected in series. But this one, since they are connected in parallel, it means to say the formula that we're gonna use basically is gonna differ from that one. It's gonna be 1 over R parallel. R parallel is equals to what? 1 over R1 plus 1 over R2 plus 1 over R3. So that is the formula that basically we use in order to calculate what? In order to calculate the resistors in what? In parallel. So here, since they want me to calculate the total resistance, remember total resistance, it means to say it's RT. Whether you say 1 over R parallel here or you say 1 over RP, it's fine. So we can say 1 over R parallel. R parallel, it equals to, we're gonna say 1 over resistor number 1 plus 1 over resistor number 2 plus 1 over resistor number 3. Then we're gonna say 1 over R parallel, it equals to 1 over, so R1 there you can see 6 ohms, so you're gonna say 1 over 6 plus 1 over R2 is represented by 3 ohms. Just gonna write 3 ohms there, and then plus 1 over our R3, which represents resistor number 3, is 1. We're gonna say 1. Now with regards to that, let us now add. Let's now add 1 over 6 plus 1/3, 1 over 3 plus 1. Let's now add and see what we're getting. So it's 1 over 6 plus, that's 1 over 3 plus, and then that's 1 over 1 over 1. So one thing that you need to understand, So one thing that you must understand is that here, let's add. What did we get? So remember, it's 1 over 6. I want to show you something. Plus 1 over 3. So that's 3 over 2. But 3 over 2 is not the answer. That's 3 over 2. Now 3 over 2, it's kind of like you saying it's 1 over r parallel. Ne? So when you write it here, you're just gonna say 1 over r parallel. We got what? We got 3 over 2. So 3 over 2 is not the answer. Ne? As we don't want the 1 over r parallel, but we want what? We want r parallel. It means to say, when we want r parallel from 1 over r parallel, we're just gonna simply swap them in order for us to get r parallel. So r parallel is gonna be equals to, so that's 2 over 3, which is gonna be equals to, now 2 over 3, let's see, 2 divided by 3, that's gonna be 0.6 or 0.67, carry 0.67. Now it's a resistor. Resistor is measured in ohms. You're just gonna say ohms. So that's how we calculated the total resistance of resistors that are in what? That are in parallel. Any question? Any question? So this is very important in order for, yes, any question? Or there's no question? Okay, sharp. Okay, sure. And then from here, so one thing, remember I've showed you the symbol of an ammeter previously, né? So one thing that you must understand, we're gonna have meters. The meters we're gonna have, number one, an ammeter that I spoke about, but I think I showed you only a symbol to say ammeter. It's like this. So one thing that you must understand is that an ammeter measures the strength of an electric current. An ammeter measures the strength of an electric current. Ammeter measures the strength of an electric current. It has low resistance. It has low resistance and is connected in series in the circuit, and is always connected in series in the circuit. So there's no way you can find an ammeter connected in parallel. It's always going to be connected in series. Number two, we're going to have what we call a voltmeter, which is like this, right? So a voltmeter measures the potential difference. A voltmeter measures the potential difference. So a voltmeter measures the potential difference between 2 points in a circuit. Between 2 points in the circuit. It has a high resistance. It has a high resistance it has a high resistance and it's always connected parallel. Connected parallel in the circuit. And it's always connected parallel in the circuit. So these are the two differences that you must know. There's no way they can connect an ammeter parallel. There's no way they can connect the voltmeter in series. So the ammeter is always going to be found in a series circuit. An ammeter it measures the current. Ne? So when we say it measures the current, if they can say calculate the current, that's when you go to that formula that I showed you. Current is this one that measures the what that is being measured by an ammeter. It means to say current, it being symbol I, which is this symbol right here. Current it being symbol I, the instrument that we normally use to measure the current, it's called the what, an ammeter. And then the instrument or the device that we normally use to measure the voltmeter, it's to measure the voltage, is called the voltmeter, so to say. Do you see? So those are two things that you must know with regards to that. So I think for now let me just leave it here, and then on the next, go and master this. On the next session for our physics, I'm gonna be now drawing circuits in series. We're gonna calculate the resistance. But this one I've just showed you the difference. We did calculate the resistance. So on the next session, I'm gonna show you how do we calculate the voltage in a series circuit. How do you calculate the current in a series circuit? How do you calculate also the current and the voltage in a parallel circuit, just like that. So for now, go and master these formulas that I've just showed you. Also know the principles of how basically we use resistors in series as well as resistors in parallel. Now the tricky part with regards to resistors in parallel is this one. You don't calculate RP. In the formula actually it's gonna be 1 over R parallel. So it means that here when you get 3 over 2, this is not the final answer. You must just swap it, because we don't want 1 over R parallel, but we want what? We wanted this R parallel. That's why here I had to swap them. And then after you swap them, it now gives you 0.67. So that 0.67 is what? It's resistance. Resistance is measured in what? In ohms. This is a symbol for ohms. Ne? So yeah, that's how basically we conclude today's session. Make sure that you do what? You go and practice, and I think you're gonna be